Well, before we talked about greatest common multiple. No, I'm sorry. Greatest common factor. Now we're going to talk about its cousin, the least common multiple. First of all, before we get too far into talking about what least common multiple is and all that stuff, I'm going to show you a couple of examples of some of the problems you're going to have on your homework. Okay? This first problem is English muffins come in packs of 8, eggs come in cartons of 12. If there are 24 students, what's the least number of packs and cartons needed so that each student has a muffin sandwich with 1 egg and that there are no other muffins left over? Oh my gosh. That sounds like a mouthful, doesn't it? And a lot of you will look at that and go, I have no idea. What I'm trying to do here is I'm trying to teach you. Let's figure out what the question is. What do you think, what's the most important phrase or question in this problem? Let's look at, let's try to figure out, what is it asking us? What is it asking us to find? Exactly. What is the least number of packs and cartons needed? So if you're looking at this problem and you go, okay, I'm going to have an answer like so many number of packs and so many number of cartons. If you can understand that, you're doing great. The first job that you guys have is understand the question. What is the least number of packs and cartons needed? Well, it said English muffin comes in packs of 8 and eggs come in cartons of 12. If there are 24 students, what's the least number of packs? Each student has a muffin sandwich. Okay. If muffins come in packs of 8, how many packs do I have to buy to get 24 of them? 3. And if eggs come in carton of 12, how many cartons of eggs do I have to buy so that I get 24 of them? 2. So my answer is this simple. 2 packs. Oh, 3 packs, 2 cartons. Okay. The answer is that simple. It's actually really easy. Okay. The hardest part is trying to understand the question. The next one. Dog cookies come in packs. Dog cookies. I think they mean dog treats, like cookies for dogs. Not what you're thinking. Okay. Dog cookies come in packs of 6. Bones come in bags of 9. If there are 18 dogs, what's the least number of packages and bags needed so that each dog can have a treat box with 1 bone, 1 cookie? What's the answer? Yeah. 3 packages of dog cookies and 2 bags of bones. Or you could draw pictures, it would help you. Just so you know. Just so you guys know that that's what dog cookies look like. Okay. Never seen them before? Well, just that's what they look like. They look like flat dog cookie. All right. All right. Let's move on to actual least common multiple. This is the new part of the lesson. This is the new thing that you probably haven't really, well, you may have done it before, but this will be a little review for you. Smallest number that is of 2 or more numbers is the least common multiple. Now, we have to understand, what is a multiple? What is a multiple? Anybody know? What's a multiple? Going once? Twice? Well, true, it is a number. What is it? No, those are factors. Whatever goes into it are factors. So if I ask you what are the multiples of 3, what would you say? No, those are factors. Multiples. What do you think?
Like 9, 6, 7, 12.
So it would be multiples of 3 would be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 41. No, 42 I mean. See? Should have quit while I was ahead. Those are multiples. So if I ask you what are the multiples of 4, you would say what? How about start with 4?
Okay, 4,
Okay, yep.
8,
Yep.
16, no, 12,
12,
16,
16,
20, 20,
20, 25. We'll just stop there. Good. Whew. Okay. Multiples are the numbers that you multiply, it's like skip counting. So if I said the multiples of 5, you would say 5, 10, 15, 20, 25, 30, and so on. Well, what we're going to be looking for is we're going to be looking for the least common multiple of 2 or 3 or maybe 4 numbers. So if I gave you this, the least common multiple of 8 and 12, well, if we made our list, we would have 8, 16, 24, and then for 12, you would have 12 and 24. Oh, there we have a common multiple. They have one in common. Least meaning the smallest value. Okay, so we have a number of different ways we can do this. We have a number of different ways we can find least common multiple. The first 2 ways I'm going to show you are long and going to take you a long time to do it and require a lot of paper, and your chances of making a mistake are pretty good. The third way I'm going to show you is not quite as long, and your chances of making a mistake are less. What way do you think I want you to use? The third way, okay? Now this one's actually very easy. The least common multiple of 3 and 4 is going to be what? It's going to be 12. Now you could, if you really wanted to, you could make a number line and you could draw a little thing and look at that, like a little bunny rabbit where it goes 3, 6, 9, 12. And then you could draw another little hoppy bunny rabbit that jumps 4, and where they first meet, right there, is your least common multiple. You could do that. Great, awesome, works cool, doesn't take up a lot of paper, unless your numbers are 72 and 56. Because now you got to make a number line that's 72 and 56, and all of a sudden your number line is stretching into the district office. And we don't have that much paper. You could do it. It could be done. But I don't really want you to. Next, you could also make a list. We could make our lists. Our lists of 4s are going to be 4, 8, 12, 16, 20, 24, 28, 32, 36, 44. And who knows, we might have to keep going. We're going to stop there for now. 5, 10, 15, 20, 25. You can make another list. And then you could go 8s. 8, 16, 24, 32. A lot of paper. And then you got to find the number. What's the number? What's the number they all have in common that has the smallest value? What do you see? 40. There it is. I would look at this and go, ooh, 20, 20. No, not there. Then you have to go find another one. Your chances of making a mistake here are pretty good, because not only could you make a mistake making your list of numbers, but then you could make a mistake trying to find the actual number they all have in common. So, way number 3. To me, any guesses? Remember what way number 3 was before we had winter break? Do you remember what I said works every time? It's just, what was the magic thing we used? Was it what? The little tree thing. The little tree. You mean a factor tree? Factor tree, I'm going to call it a factor tree. And I'm going to call it prime factorization. We can use prime factorization for this as well. And it works pretty easily. So if you don't know how to do it before break, you better learn how to do it now. We can use prime factorization to find least common multiple. Now, a lot of you can look at these and probably figure them out and know what it is off the top of your head. But what if I give you numbers like 134 and 76? There's no way you're going to be able to do least common multiple with a couple of big numbers. Use prime factorization. It works the best. Now, remember, to find prime factorization of each number, we make our little trees. What goes into 6? 2 and 3, both prime. What goes into 20? 5 and 4. 5's prime, 4 is not. 2 and 2. Same thing, right? Watch this. Same setup as before, too. Nothing changes as far as the setup goes. 6 is going to be 2 and 3. 20 is going to be the same. We have a 2 column. We have a 2 column and a 5 column. Right? We've got all that. Has anything changed from what I taught you before break? Nothing has changed. This is exactly the same. You set it up the same. The reason I had you set it up before break was for this reason, because I wanted you to know how to set it up. Because watch. Now, before, in order to find the greatest common factor, we would have just done the columns that are full, right? And our greatest common factor here would have been 2. Well, for multiple, we just use all the columns, whether they're full or not. 2, 3, 2, 5. Multiply them together. What is it? 2 times 3 is what? 6 times 2 is 12 times 5 is? My answer is 60. Okay? You just multiply them all together. It's the only difference between least common multiple and greatest common factor is with least common multiple, you use all of the columns. With greatest common factor, you only use the full columns. Okay? It's the only difference. Kevin. If you don't need to, you don't have to. If you want. You have to use the columns. You have to use the 2, 3, 2, 5. Yes. On your whiteboards, I would like you guys to try this one. So our prime factorization for 15 was 5 and 3. Prime factorization for 6 is 2 and 3. Prime factorization for 4 is 2 and 2. So we do our columns. We have 15 is 5 and 3. For 6, it is 3 and 2. And for 4, it is 2 and 2. So then we have these columns right here. 5, 3, 2, 2. 5 times 3 is what? 15 times 2 is? 30 times 2 is? 60 is our answer. I'm not going to have you do it that way. Well, you can. Go ahead. Try it. What is it? 6. 6. Go ahead. Try that one. No, I don't want you to use a list. When it tells you, even on your homework, if it tells you to use a list, if it tells you to do that, I don't care. Use the factor tree. That's what I want more. I want you to use the factor tree for this. Don't make a one column. Good. You're all good. 3 times 2 is 6, times 2 is 12, times 3 is 36. All right. I'm done. I'm going to have you do page 230. 16 to 36 even.